Hi, this is Maggie. In this video, we're going to solve a data analytics problem using some Python analytics libraries. Before we get started, I'm going to quickly give you some tips for how to get the most out of this video. First, if you have problem solving with Python, read up through Chapter 9. If you don't have it, you can still learn a lot from this video. Open up Spider and follow along with Python as I work. Sometimes I'm going to suggest you pause the video and complete some steps on your own. When I do that, pause the video and do your best to complete the steps on your own. The way to learn to program is by programming. You can watch and learn if you work along with me. Remember, you can always pause the video and try something or go back and watch again. You don't have to wait for me to tell you to pause. Now let's get started. I've chosen a straightforward problem for us to solve that will allow us to practice with pandas and matplotlib and some general data analytics concepts. We're going to recreate some charts that are available on ourworldindata.org. There are at least a couple of advantages to recreating somebody else's chart. First, it allows us to check our answer once we've produced the chart. If we don't produce the same chart using the same data, then we have probably made a mistake or misunderstood something. Second, unless we're experienced data scientists or data analysts, it will guide us in following best practices. And third, it gives us the opportunity to explore some data that's already been collected and learn something about the topic we explore. I've chosen this data, which is the environmental impacts of food. I'll include a link in the description to this page. In fact, you might follow along and download the data with me so you can work along with the video. So go ahead and pause the video, click on the link in the description, and get this page open in your browser. Pause now. Great. Hopefully now we're on the same page. I'm excited about this because I've read stories about the environmental cost of producing different foods, and I think that should impact our food choices when we have a choice. And in looking at this data, I already learned a new word, eutrophication, which refers to environmental damage caused by nutrients like nitrogen and phosphorus running off the land into a body of water. Okay, so let's take a look at one chart and try to recreate that one. This chart is greenhouse gas emissions per kilogram of food. And at first I thought these might be the foods with the highest values, but then I realized there are checkboxes off to the left, so you can pick whatever foods you want to see in this chart. If we look at the source of this data, the authors, Michael Clark, Marco Springman, and Mike Rayner, looked at 57,000 food products. I'll link this source in the description of the video as well, although you won't need it to follow along with the programming. So it's a bar chart with foods on the left, kilograms across the bottom, and the bars are labeled and they're all different colors. So to recreate this, we'll need to download the data, load it into a pandas data frame, take a look at it, and then see if we need to do any sort of manipulations to pull out the data we need for this chart. Then we'll need to create the chart. So first thing, click on the download button and choose full data CSV to get a comma-separated values file of the data used to produce all of the charts here. Store that in a directory that you'll use for this project. Now open up Spider and let's create a new file and read the data in. So first we'll import pandas as PD, and then we'll create the data frame, food footprints, equals pd.read_csv, food-footprints.csv. Now, hopefully that goes right. If not, check the name and location of your file. This CSV has no extra lines, no footer explaining the data. It's ready to be read into a data analytics program. But let's use some of the tools we have available in pandas to look at this data and get a sense of the shape and range of this data. So over in the console, I'm going to try food_footprints.columns to see the names of the columns in the data frame. And there are a lot. For example, we have emissions per kilogram, emissions per 1,000 kilocalories, emissions per 100 grams of protein, emissions per 100 grams of fat, and I'm thinking entity is the kind of food. Let's type food footprints and then select the entity column by putting the string entity in square brackets. And it looks like there are only 211 rows in this data frame, so not all 57,000 food products that were studied. If I read the information under the tab Sources, On the World in Data website, it says that they've combined the original products into higher level categories, and these categories use weighted ratios according to how the ingredients are combined to make the food. Let's see if there are any missing values in the table. I doubt there are, only because this data has been manipulated from the original source, but let's look at the whole table first. If we type food footprints.isNA, we will get a table the size and shape of our data frame with true in a row column cell if there's an NA there, and false otherwise. So we can see the table is elided, and there are a lot of false values, but we need to know if there are any true values. So let's sum up first each column. So food footprints .isNA .sum. Let's type it correctly. And look, there are several columns that have 2 NAs each. I wonder if they're the same foods. They're all protein columns. So I wonder if those are foods without protein. How can we quickly find out which rows those are? What I want is to select the rows that have an NA value. I can do that with a Boolean array. A Boolean array will be a filter. Where there's a true, the row will come through into our result, and where there's a false, it won't. This is a good time to pause the video and see if you can figure out how to make a filter like that and apply it to the data frame. Pause the video and see if you can create a Boolean array that will allow you to pull out the rows with NA values. Pause now. How'd you do? So for our array of Booleans, let's use that first protein column, emissions per 100 grams of protein. So we'll pull out that column, food footprints sub emissions per 100 grams of protein, and then type .isNA, and that will give me an array of Booleans for just that column. We'll use that to select out of food footprints. So we'll put before that food footprints open square bracket and close square bracket after it. I'm going to store that in a variable called NAs. And then I'm going to click in the variable Explorer tab and double click on NAs. And if I scroll through the columns, I can see 2 rows with not a number values for 6 protein columns, and those foods are olive oil and sunflower oil. Perfect. We found all the not a numbers in the data frame. If you're working with data that's more raw than this, you'll want to spend a lot of time understanding what you have. The full range of values for each column, whether they were read in as the proper type or maybe something in the original file caused them to read in as text, and where there's missing data. And there are ways to deal with each of these situations, but they vary depending on what you have, how it was collected, and what you're trying to do. We're going to move on to creating our visualization. So I think it would be very interesting to order these values and create a chart showing the highest and lowest, for example. But it makes sense for an interactive visualization like this one to allow people to choose the foods they eat regularly. One thing I read recently is that beans are a healthy food that's good for the environment. So I'm going to add beans to this visualization to see how they measure up in terms of CO2 emissions. Pretty good. Better than beef, eggs, and milk, certainly. Okay, so let's make a data frame that is just the name of the food and the greenhouse gas emissions per kilogram. Those are columns. And just the rows listed here. Beef burger, macaroni cheese, meat pizza, eggs, rice, cow's milk, vegetable lasagna, coconut milk, lentils, dairy-free ice cream, tomatoes, vegan pizza, beans, avocados, bread, bananas, almond milk, almonds, potatoes. And I do want to point out we're only looking at one dimension of environmental impact here. So if you're interested in the environmental impact of foods that you like, I'd suggest reading the article and looking at all of the tables. but maybe you can guess what I'm going to say. Pause the video and see if you can create a data frame with just those rows and columns. I'm going to give you a hint. You might want to create a list of the foods that we want to select for and use isIn, which is similar to the in operator in Python. I'm going to show you an example. Food footprints, subentity, .isIn, the list, ale, almonds. This will look at each element in the entity column, which is the name of the food, and check if it's in the list, ale, almonds. And notice that I get 2 true values and the rest that we can see false. I can use this vector of Boolean values to select rows from my data frame. Okay, so see if you can construct a data frame of just the columns and rows that we want. Pause now. How do you do with that? I'll bet you figured out at least part of it. Okay, so here's what I have. I've already typed it in because the list is a little bit long. The first thing I did was select the columns we're interested in. I stored that in a data frame called greenhouse. So I wrote greenhouse equals food footprints, and then the list, emissions per kilogram entity. So we're selecting, and then we pass in a list of the columns we're interested in. And then I created the list of foods we're interested in called foods. That was simple, except initially I had a smart quote for the quote in cow's milk. So that wasn't getting into my final data frame. I had to make sure that was a regular quote. And that is just a list of strings. The strings have to match the values we want from the entity column exactly. And then I used isIn. The Boolean array is achieved by writing a greenhouse subentity isIn foods, and I used that to select from greenhouse. I stored the result in the data frame food rows. And if we look at that over in the variables area, we can see our selected foods and their emission values. Now we want to create that chart. We're so close. Let's get this data frame in order from highest to lowest first, though. We can use the data frame method sort_values to do this, and we pass in the column we want to sort by. So we'll write sorted rows equals foods rows dot sort_values by equals emissions per kilogram. And if we examine that object, we can see that it's the same data, but sorted. We're now ready to create our bar chart. Now I'm going to bring up the documentation for bar H. We'll import matplotlib.pyplot as PLT and write figax equals plt.subplots. And now see if you can pause the video and create a bar H plot from our data. Pause now. How'd you do? If you made the plot, you must be pleased at how close we are to our goal. For my code, I'm also going to import a color library so we can have different colored bars, although I'm not sure what colors are being used in the plot we're trying to imitate. I'm not going to worry too much about getting the same colors, so I'm going to put at the top import matplotlib.colors as mcolors. And then at the bottom, after creating fig and ax, ax.barh, open parentheses, and for the y-axis, sorted rows, subentity, and for the x-axis, sorted rows, sub-emissions per kilogram, and then color equals mcolors dot tableau colors, which are fine for now, although I'm not sure they're good for color blindness as they contain red and green. And when I run that and click the Plots tab, we get a horizontal bar plot ordered from largest value to smallest, top to bottom, with the bars different colors and the names of the foods along the vertical axis and the CO2 values along the horizontal axis. Now, I am not an expert on matplotlib, so to modify this chart so that it looks like the one on World of Data's website, I'll have to look at the documentation. So what we want to add is labels on the bars showing the numerical values of the bars. This is good information because it can be a little hard to figure out those values from just the image. I found in this bar label demo tutorial, the second example is a bar H chart with labels. And if I look at the code, I see ax.barlabel h bars fmt equals quote percent 0.2f quote. And what is h bars? I look up in the code, and that's the object returned from bar h. So I'll do the same thing. I'll put bar h equals in front of my ax.barh call, and that will give me the bar h artist as an object that I can send messages to or pass as a parameter. And I'll use this exact code. plt dot bar underscore label h bars, comma, fmt equals percent 0.2f. And that's great. Although in the original the values aren't all formatted to 2 decimal places. I'm not going to be picky about that at this time. Let's get the title on the chart, as that's easy. ax.setTitle greenhouse gas emissions per kilogram of food. Okay, 2 more things, I think, and this will be a reasonable approximation of the other chart. Let's label the x-axis with kilograms. And let's make the chart large enough to enclose all of the labels. There is an axis method that returns the dimensions of the axis. If I type into the console ax.axis, I get back a tuple 0.0, 56.675, etc., negative 1.34, 19.34, etc. That gives me basically 2 pieces of information. First, it tells me that those tick marks on the bottom are every 10 units, and so that tells me where to put the labels I want to put in. It also gives me a starting point for new values I could enter that will give me a larger plot area. So I'm going to try ax.axis 0, 60, negative 2, 20. And when I run that, my labels fit within the window. So finally, turning to the x-axis, I can see in the bar label demo document, in the first plot, that the axis has different labels. The first parameter is the list of locations, and the second is the list of labels, and that's a keyword argument called labels. So I'll type ax.setxticks, the list 0, 10, 20, 30, 40, 50. Labels equals the list of strings 0 kilograms, 10 kilograms, 20 kilograms, 30 kilograms, 40 kilograms, 50 kilograms. And I'll run that. And I'm pretty happy with that plot. I think reproducing plots is a good way to learn because if you don't know how to get the exact data configuration or plot appearance that you want, you learn more about how to manipulate data frames or use matplotlib. To continue to practice with this, I recommend you rewrite what I've written here as always. If you want to modify the chart in other ways, I say go for it. It's good practice. You might recreate some of the other charts on the website using this same data set. Since you already have the data set, and we've already worked to understand it some, have fun with it.